Morning, everybody. It's Miss Sprunner. Today is the 20th. It's Tuesday, and we are going to go over a little bit what we did yesterday and working on some new stuff. So if you guys remember, we're starting a new unit called Proportional Relationships. So our do now today is what is the name of K in the formula K equals Y over X. And then the second part that it says, a graph is proportional if it has what two properties? We talked about this yesterday, so go ahead and think about them for a few seconds and then we'll go over them. All right, so what is the name of K in the formula K equals Y over X? It's going to be the constant of proportionality. So remember, K is constant of proportionality. And that is the relationship between Y and X. So Y and X, the ratio is K, and that's a constant of proportionality, so it's always staying the same if K is the same between every Y and X point. A graph is proportional if it has what two properties? You guys remember from yesterday, if a graph is a straight line, and if it goes through the origin. So if you guys remember what the origin is, that is 0.00 in the graph. So if we're looking at a graph, if this is going to be your Y, your X, it's going to be a straight line through 0, 0. It's going to be a straight line. That's going to be a proportional relationship on a graph. All right, we're going to move on with what we're doing today. So this says, which of the following tables represents a proportional relationship? We've got a table, we've got 1, 0, 4, 3, 7, 6, 10, 9. So I don't really know what the relationship is here initially, but I can go ahead and say, so I can try and find the constant of proportionality. So remember, to find that, we're going to do K equals Y over X. That's parable X, sorry. So K equals Y over X. So I'm going to take 0 divided by 1, because I've got 0, which is my Y, divided by 1, which is my X, which gives me K. Well, in that case, 0 divided by anything is going to give me 0. So that's going to be K equals 0. So that means the change in K is going to be 0, which means the change in all of these would be 0, which doesn't make any sense. So this one is not a proportional relationship. B, we've got 4, 6, 6, 9, 8, 12, 10, 15. So I'm going to go ahead and set up another K equals YX situation. So I'm going to take my Y. So I've got 6 over 4. So 6 over 4 is going to give me K. So 6 divided by 4. Is going to give me 1.5. So now to see if it's proportional, I'm going to take the next point. So I'm going to take 9 and 6. So I'm going to divide 9 by 6 and see what that gives me. 9 divided by 6 gives me 1.5 as well. Just to double check, I'm going to do one more point. So I'm going to do 12 divided by 8. So 12 divided by 8 equals 1.5. So our constant of proportionality here is 1.5, and that checks out for all of these. So B is a proportional relationship. All right, let's look at C. We've got 2, 4, 6, 8, 3, 4, 5, 6. So it looks like there's a trend going, but we're going to use our K equals Y over X formula to figure it out if it's truly proportional or not. So we're going to take 3 divided by 2. So 3 divided by 2 equals 1.5. All right, but then we get to this next one. 4 divided by 4. Well, I know 4 divided by 4 is 1. So since the rate of change, that K, that constant of proportionality, isn't constant, that's not going to be a proportional relationship. Sorry, that was supposed to be an X. Not a proportional relationship. All right, this next one, we've got 2, 3, 4, 5. We've got 3, 6, 9, 12. It looks to be like there's a pattern, but I want to make sure. So I'm going to use my k equals y divided by x formula to figure that out. So I'm going to take 3 divided by 2. So I'm going to take 3 divided by 2 equals 1.5. And I know that because of what we did earlier. All right, I'm going to take 6 divided by 3. So 6 divided by 3. Well, I know 6 divided by 3 is going to give me 2. So since 1.5 and 2 are not the same, this is not a proportional relationship. So I know we picked B initially, but I wanted to make sure that we were all on the same page, that all of these were not proportional before I made sure that B was my correct answer. So B is going to be our proportional answer in this. And you will see something similar to like this on the air test. So just make sure that we are aware what a proportional relationship looks like and means in a table context. All right, cost of data. So is this a proportional relationship? Is this proportional? Is this relationship proportional? So if we look back to our graph properties, to see if it's proportional, it says it has to have a straight line and go through the origin. So if we look at this, it looks to be pretty straight, and it does go through 0, 0. So yes, it is proportional. Write the equation. So since it is proportional, we should be able to take this graph and write a k equals yx formula equation. So k equals y divided by x is going to be our formula format. I'm going to take, so I'm noticing I've got 40 and 1. So that's where these 2 points meet. I have also got 2 and 80. So I'm going to use those to start to figure out my constant of proportionality. So I'm going to use 40 is my y. So 40 divided by 1 equals 40. 80 divided by 2 equals 40. So it looks like our proportional relationship is going to be k equals 40. So k equals 40 or k equals 40 over 1. That's going to be our equation for this one. Does the table below represent a proportional relationship? So we've got x and y, we've got a table. So remember, we can actually take, so using the formula, we can actually, or the equation format, we can, we should be able to get a graph from a table. We should be able to get a table from a graph. We should be able to do all sorts of things. So once you figure out what you like best, you should be able to use that to your advantage to see whether or not a graph is proportional, whether or not a table is proportional, that kind of thing. So again, k equals y divided by x. So does the table below represent a proportional relationship? So I'm going to go ahead and I've got 6 divided by 2 because I'm going to take y divided by x. So k equals 6 divided by 2. I'm going to take 7 divided by 3. So k equals 7 divided by 3. And finally, I'm going to take k equals 8 divided by 4. So I'm going to see whether or not these are proportional by seeing what their ratios are. So 6 divided by 2 is going to give me 3. 7 divided by 3 gives me 2.33. Well, already it's not proportional, but 8 divided by 4 is going to give me 2. So because these numbers are not the same, this is not a proportional relationship. K is not constant, therefore it is not a proportional relationship. Is this relationship proportional? So we've got a graph of grams of protein and ounces of nuts. So this is our graph. We want to know, is this relationship proportional, yes or no? So if you look back, it is a straight line. Does it go through the origin? So the origin would be right here. So it starts right here though. So no, this is not, oops, didn't mean to do that. So no, Why is it not proportional? It doesn't go through 0, 0 or the origin. All right, the graph below represents how many chips Rebecca eats in an hour. So we've got Rebecca's over here. Let me get my highlighter really quick. So we've got Rebecca, she eats in a certain amount of chips. The equation represents the rate at which Leela eats chips. So find out who eats more chips in 3 hours. So we are trying to figure out who eats more chips, Rebecca or Leela. So we're comparing a graph to the equation. So in this case, the y equals 15x. We talked about this a little bit yesterday, how, let me get my pen. How another way we can write, so we can write k equals y over x, or we can write y equals kx. In this case, that 15 is going to be the constant of proportionality for Leela. So I'm looking over here, so I'm going to turn this graph into an equation, so I can do that. So I'm noticing that so the hours right here, this is going to be my x, and this is going to be my y. So if I'm looking at this, I'm noticing that at 1 hour, I've eaten 12 chips, or Rebecca's eaten 12. At 2 hours, she's eaten 24. At 3 hours, she's eaten 36. At 4, she's eaten 48, and so on and so forth. So we could create a table. However, I'm going to write an equation first. So I know that I'm going to try and find her constant of proportionality. So I'm going to go ahead, and from this, I'm going to go ahead and do k equals, I'm going to take y, so I'm going to pick 12 over 1. That's when those points meet, so 12 over 1. So k equals 12. So for Rebecca's equation, so I'm going to write Rebecca. Her equation is going to be y equals 12x. So this means that she eats her at a rate of 12 in any number of hours times 12, she will eat that number of chips. All right, and then we've got Leela, and she eats at a rate of 15 chips per hour. So we want to know who is going to eat the most chips in 3 hours. Well, number of hours is going to be represented as x, so I'm going to replace the x here with 3 on both of these equations. So I'm going to have y equals 12 times 3, and y equals 15 times 3. So for that first one for Rebecca, I'm going to do 12 times 3, which gives me, and so in 3 hours, Rebecca's going to eat 36 chips. And for Leela, we've got 15 times 3. So in 3 hours, Leela is going to eat 45 chips. So who will eat more chips in 3 hours? Leela. All right, same thing over here. The graph below represents the rate at which Melanie listens to songs. So we're comparing Melanie, we're comparing Melanie, her graph, to Jesse's equation. So we want to say, it says the graph below represents the rate at which Melanie listens to songs. The equation represents the rate at which Jesse listens to songs. Over a day, who listens to more songs? So we're trying to compare this table to this equation. So since we already have the equation, I'm just going to go ahead and make an equation from Melanie's graph, just like we did earlier. So if we remember correctly, we've got x and y. So at 1 hour, she listened to 4 songs. At 2 hours, 8 songs. 3 hours, 12 songs, and so on and so forth. So she's doing it at a constant rate. So I'm going to go ahead and do my k. So if we remember, we've got k equals y divided by x, and then y equals kx. So I'm going to go ahead and do y, which is 4 in this case. So, oops, didn't mean to do that. So 4 divided by 1 equals 4. So our constant of proportionality for Melanie is k equals 4. So for Melanie, her equation is going to look like y equals, and that rate at which she listens to songs is going to be 4 songs per hour. The rate in which Jessie listens to songs is going to be y equals 2x, because they already gave that to us up here. So now we're going to go ahead and compare these two. So it says, over a day, who listens to more songs? So this is kind of tricky because it says over a day, but so if x is hours, we need to think of how many hours are in one day. 24. So I'm going to go ahead and replace x with 24 in both of these. So y equals 4 times 24. And I'm going to replace y equals 2 times 24. All right. So y equals, and then 4 times 24. So 96. And then Jessie, 2 times 24 equals y equals 48. So in a day, Melanie is going to listen to more songs than Jessie. Let me know if you guys have questions going through this. All right. The graph displays how many chocolates Jameson eats over the course of 5 days. So we've got a graph, we've got Jameson. So Jameson is in our graph, and then Ezra is in our equation. So we're trying to find the rate at which the two boys eat chocolate. Find out who eats more chocolates over 5 days. So I'm going to do the same thing we've been doing. I'm going to look at Jameson's graph. So remember, number of days is going to be our x, number of chocolates is going to be our y. So in 1 day, he eats 5 chocolates. In 2 days, he eats 10 chocolates. In 3 days, he eats 15 chocolates. So he's doing it at a steady rate because it's a straight line that goes through our origin. So we know the equation for Ezra already. So we need to figure out the constant of proportionality for Jameson. So if we remember, we got to find out the constant of proportionality by setting y divided by x. So what I'm going to do is I'm going to take my y, so I'm going to take 5 and then divide it by my x. So 5 divided by 1, so k equals 5 divided by 1, which k equals 5, because 5 divided by 1 is 5. So Jameson's equation, so for Jameson, his equation is going to be y equals 5x. So that means 5 times the number of days is going to give us the number of chocolates he eats in 5 days, or in any number of days. So for Ezra, our equation is up here already. So we've got y equals 4x. So this means that he eats chocolate at a rate of 4 chocolates every for any number of days. So to figure this out, we want to figure out who eats more chocolates over 5 days. I'm going to go ahead and plug in 5 for x in both of these. So I'm going to go ahead and write y equals 5 times 5. Y equals 4 times 5. So now I'm going to go ahead. 5 times 5 gives me 25. 4 times 5 gives me 20. So remember, if we remember what y means, y is the number of chocolates. So who eats the more chocolates in a number of days? Jameson. And that makes sense because his rate is 5 chocolates in a day, where Ezra's is 4 chocolates in a day. All right. Might be our last thing we're going to do today. The graph below represents how many water bottles Seth sold. The equation represents the rate in which Hayden sold water bottles. Who sold more water bottles? So I'm going to go ahead and highlight. So I've got Seth, he sold numbers of water bottles from the graph. And then we've got Hayden, who sold water bottles with that equation. So we're comparing the two right now. So I'm going to turn this graph into an equation. I need to find the constant of proportionality. So remember, we've got X and we've got Y. So at 1 day, he sells 10 water bottles. At 2 days, he sells 20 water bottles. At 3 days, he sells 30. At 4, he sells 40, so on and so forth. So pretty standard or pretty consistent rate. So we need to find the constant of proportionality. Remember, K equals Y over X. So to find the constant of proportionality, I'm going to take my Y and divide it by my X. So 10 divided by 1 gives me 10. So the constant of proportionality for Seth is going to be 10. So if we want to write an equation for Seth and an equation for Hayden, Seth, we know his constant of proportionality is 10. So we've got Y equals 10x. Hayden's is going to be Y equals 11x because they already gave that to us. So where X equals the number of days, so his rate is 10 bottles a day, giving us a total number of bottles. And Hayden's is 11 bottles a day he sells, or she, I don't know. So we want to figure out who sold more water bottles, and that's at any given day. So we just want to know who sold more water bottles. Well, I can already tell Hayden's got a better rate, but let's just say after 5 days. So I'm going to plug in 5 for X. So I'm going to say after 5 days, who sold more water bottles? So 11 times 5. So Y equals 10 times 5, which is 50. Y equals 11 times 5, which is 55. So Hayden in the long run is going to sell more water bottles if he's selling the rate at the rate of 11 bottles per day. All right, we're going to do this as an assignment tomorrow. So I guess what I want to say to you guys is make sure that you're checking Google Classroom, make sure that you are watching the videos, make sure that you are submitting your work in. If you're late, that's okay. Just make sure you get it in because the quarter ends tomorrow. So just make sure I can get in all your grades in an appropriate time frame. I will see you guys tomorrow. Actually, tomorrow's a remote learning day, so I will be posting a video for you guys to watch. But tomorrow is a remote learning day, so I will not be live on here because I will be having meetings, but I will be posting a lesson for you guys to do. All right. I will see you guys Thursday and have a great day. Bye.